On this map, Greenland and Africa look roughly the same size. Maybe Africa is a little bigger, but they're in the same ballpark, right? But here's the deal. Africa is actually 14 times larger than Greenland. 14 times! And maps like this one didn't just get it a little wrong, it got it catastrophically wrong. This is the map many of us grew up with. It was the one that was in my classroom and possibly yours as well. Thing is, maps like this portray a distorted version of reality. Let me show you how. Let's start with what we think we know. This is the Mercator projection, probably the most common world map of all time. And on this map, certain things look off, but you might not have noticed because at this point, this is just what a world map looks like to many of us. Greenland looks massive. Russia also is enormous. Alaska and Canada are ominous giant land masses. And Africa, it looks fine, normal sized. Now, here's what these places actually look like when you correct for the distortion. Africa. The entire United States fits inside of Africa. So does China. So does India. You could fit most of Europe in here too and still have room left over. Africa is absolutely massive. Greenland, it's roughly the size of the Democratic Republic of Congo. That's one country inside of Africa, just one. Alaska, which looks huge on this map, is actually smaller than Libya. Considering that these are the maps that are in classrooms, on walls, in movies, the one you've seen 1,000 times, it has subconsciously and fundamentally distorted your perception of what Earth actually looks like. Okay, but why? If this map is so wrong, why is it everywhere? Why did we all grow up with this thing? Why is it still in use today in Google Maps? Here's the thing. The Mercator projection wasn't designed to teach geography. It was designed in 1569 by a Flemish cartographer named Gerardus Mercator, and it was made for one very specific purpose: ocean navigation. And for that purpose, it's actually brilliant. If you're a sailor in the 1500s, you need to be able to plot a course on your map. You need to draw a straight line and have that translate into a constant compass bearing. North-northeast the entire way, for example. Mercator does that perfectly. Any straight line you draw on this map is a line of constant direction. Works great for navigation and is why it's still the most used map projection of all time. The trade-off: to make that map work, you have to stretch land masses the further you get from the equator. The poles get absolutely massive on the map, even though they're tiny in reality. Countries near the equator stay relatively accurate, but the further north or south you go, the more distorted everything becomes. Mercator knew this. He understood the trade-offs. He never intended for this to be hanging in classrooms or living rooms. It was a tool for sailors. But it became the standard anyway. So why did a 450-year-old navigation tool become the default way we visualize the planet? There are a few reasons. First, and this is worth acknowledging, the Mercator projection was created during the Age of Exploration. European powers were colonizing the world, building empires. And on this map, Europe looks pretty impressive. Britain, which is actually smaller than the state of Oregon, looks massive and imposing. Scandinavia looks huge. Meanwhile, Africa, which is bigger than all of North America, looks rather compact and manageable. Was this intentional? Probably not at first, but it is worth noting which version of the world stuck around for centuries. Second reason, it just became normal. Once Mercator was the standard, it became what a world map looked like in people's minds. Straight edges, Greenland big, Antarctica stretched across the bottom. Everything else kind of looked weird or looked wrong. And third, practically speaking, Mercator is easy to work with. It's a rectangle, easy to print, easy to hang on the wall, fits nicely in a textbook or a frame. A lot of the alternative projections are ovals or interrupted shapes that are just harder to deal with. But here's the problem. We stopped using paper charts for navigation decades ago. We have GPS now. We have satellites. We have digital maps that recalculate in real time. Yet this 450-year-old sailor's tool is still the default way most people picture Earth. And I think that matters. So what's the alternative? Well, there are actually dozens of different map projections out there. And here's the thing about map projections. You can't have it all. You're taking a sphere and flattening it onto a rectangle. Something has to give. So every projection makes trade-offs. There's still no such thing as a completely accurate flat world map. This is the Gall-Peters projection, also called an equal area projection. This one prioritizes accurate size. Every country is shown at its true relative area. Africa looks huge on this map because it is. Greenland looks small because it is. The trade-off? Shapes get distorted, especially near the equator. Countries look stretched vertically. It's a little weird to look at if you're used to Mercator. This is the Robinson projection. It's a compromise, a little bit of distortion everywhere, but nothing too extreme. It's not perfect for size, not perfect for shape, not perfect for anything really, but it's good at everything. National Geographic used this one for decades. This is the Winkle triple. Another compromise projection that tries to minimize distortion of size, shape, and distance all at once. This is what National Geographic uses now. And there are even more experimental ones, like the orthograph, which tries to unfold the globe like origami. Still pretty niche, but interesting. So which one should you actually have on your wall? Here's what I think. If you're going to have a world map in your home, and obviously I think you should, it should at least show you what the world actually looks like. I sell maps for a living, so I've spent a lot of time thinking about this. And my recommendation? Get an equal area projection or a Robinson projection, something that prioritizes accuracy over historical convention. Because here's the thing about maps. They're not just decoration. They also shape how we see the world. If you spend your whole life looking at a map where Africa looks small, where Europe looks massive, where distances are completely wrong, that affects how you think. It affects how you understand geography, how you think about travel, how you process the news when you hear about a place. Maps matter. The version of the world we look at every day matters. So yeah, Greenland is not the size of Africa, not even close. And maybe it's time we all started looking at maps that actually show us the Earth the way it really is. If you want to see the maps that we print, I'll put a link in the description. And if you learned something today, let me know in the comments. What surprised you most? Did you already know about this? I'm curious. Thanks for watching.